daily challenge question, which is 1035 uncrossed lines. Today's question is kind of a tricky one. So if you did not read the problem, do not worry. We'll try to understand the problem via an easy example. So let's take this particular example. So as per the question, we have to connect two different arrays by vertical lines, and we can, so this is the array 1 and this is array 2. We have to place one array below to the above one, and when the element of both the arrays are equal, we can draw a line. Okay, so in this case, so 2 is similar to, so let's take this is array 1 and this is my second array. So when both the array elements are similar, we can draw a line like this, but here is a catch. So we cannot intersect between the lines. So in this example, 4 is also similar to second array, but we cannot draw this line. Okay, so this is a valid line, but this is not a valid line because these two lines are intersecting each other. So how we can avoid intersection? We have to come to now move forward to previous indexes and create new lines. So now 1 is similar in both the arrays, and we can make a line and we can connect both the elements. So in this way we have to approach this particular problem, and at the end we have to return the maximum number of connecting lines we can draw in this way. Okay, so we'll try to understand the problem in step-by-step manner, so you also by yourself get the intuition what we need to achieve in this problem and how we can tackle. Okay, so this is an easy example, and here you are also easily able to solve this particular example, but let's try to take a different example. So okay, and here let's say this is ARR1 and this is ARR2. Okay, so here what should be the answer? Okay, so let's take, so I can connect 3 with this particular 3, but after that I cannot connect any element with the second array of array 1 because there is no element present after this particular 3 in the second array. Okay, now, and we cannot connect to this with 2 because intersection can happen. Okay, so in this worst case the answer can be 1. Okay, let's try this thing. Okay, the same thing will happen now after this particular index. Let me write the index as well. So 0 1 2 3 4 0 1 2 3. So these are the indexes, so you will not get confused. So 3 is connecting to the second array 3, but after 3 we cannot connect any another element. Okay, so in this case answer will not be modified, but when I come to this 2, I can connect this 2 with this particular 2, and after that I can connect this particular 3 with this particular 3. So in this case the answer is getting maximized, and the answer for this particular example is get 2. So I hope from this example you get a better understanding to understand the problem statement. What is the critical part in this question we have to particular solve. Okay, so let's try to understand from the above example only. Let me write it down again. So 3 3 2 3 3 1 3 1 and 2. Let me write the indexes 0 1 2 3 4 and 0 1. Let me write it below so we can connect lines. So our first intuition by seeing by understanding the problem statement, so we able to get the intuition like we need to find out the particular index of the array 1 into array 2. So if we are able to find out the this element in my second array, the sub problem I have to solve from the finded index -1. Okay, so for this example, for index 4 of array 1, I am able to find out the index where the elements are matching in the second array, which is index 1. Now the sub problem will become this much only. Okay, so for now this sub problem we have to solve in the same manner. So we can see, if I go into sub problem by sub problem, I can solve this problem easily. And by sub problem, I want to give you intuition like we can move towards recursion. Okay, now recursion is here as well. But can by using this approach only we can solve this particular problem? No. Why not? Because if I stick to this particular index, like if I have to include this particular 3 in my answer, then as we seen above, it is giving me not the maximized answer. So we have a element of choice here that I can skip. What is the choice? I can skip this particular element, or I can include. I can include this particular element. Okay, so as we seen in above example, when we are understanding this, so when we skip this particular thing, we get a better answer. So at after, now there is one more catch. So in this example, we are able to find the exact element in the second array for this particular index of array 1. Now what if the case, let's suppose there is one more 4 here in this particular array ARR1. Okay, so and the index is 5, so I started from 5th index. Do I able to find out this particular index element in the second array? No. So if I'm not able to find this particular element in my second array element, so what the choice I am getting at the end? I have to, for this particular case, let's say this is case 2. So for case 2, I do not have any another choice. I have to jump to my sub problem. Now what is the sub problem begin? So I hope you are getting the intuition like what will be the sub problem now. So now the sub problem will become only this particular array, and the sub problem, as you can observe, we did not change the index of the second array, we just decrease the index of the first array, because we are not able to find this particular element in the second array. So we are jumping to the sub problem by decrement this particular index and starting from this particular index where the array 2 index does not get changed, and the sub problem is introduced to ourselves. Okay, and the two cases, and after we find out the if the index element is present in the second array, then we can go with this element of choice. And after solving all the sub problems, we get all the maximized answer. Now there can be similar sub goals again and again. So for that, to optimize this particular thing, we will use memoization. So I use top to bottom approach as we discussed. Okay, top down approach of DP, where we know the large problem, and by solving large problem and breaking down into sub problems, that approach is nothing but known as top down approach. So in this manner we only will write our code and see it. Okay, so let's jump to the code and try to understand this particular. I hope you are getting the intuition what we are going to do now. Okay, so let's jump to the code base. Okay, so I initialized a DP where we will store our memoized answer. So for the similar recursive subgoals, and m and n are storing the nums1 and nums2 array lengths, because nums1 and nums2 array can be of different lengths. Okay, then I return a traverse function, which is nothing but a recursive function. Okay, so top current index and the bottom current index at the initially are pointing towards the last index of both the arrays. So 3 3 2 3. Let's write down the similar example below as well, so we get an understanding while understanding the code. Okay, so this is the example only we are going to see. So at initially both, so there is one more 3 here. So initially both top current index and bottom, so for easiness I mark this array as top and this particular array as bottom. At initially top current index and bottom current index marking as here. Okay, and if top current index or bottom current index went out of the flow of the array, then simply we will return 0. And this here we did memoization call. If dp of top current index and bottom current index have some pre-computed value, then we simply return that thing. Okay, now what is this index? So I return a method named as getIndex, so where I am finding this particular element from this bottom current index. As you can see, I am sending bottom current index. This is my target value and this is the array where I have to find out the particular index element. Okay, so this is the getIndex method. And current index, what is current index representing? From where I have to start iterating into the bottom array, and when I find out the particular index element or my target exists in bottom array, I will return the ith index, else I will return a -1. Now the three cases which we discussed above came into picture. If index is equal to -1, what does it mean? Like this element, the case where we introduce 4 in our array which is not a part of bottom array, in that case the answer from getIndex is -1. And if the index is -1, then I am doing a recursive call to the traverse function where I am saying top current index -1. So I introduce a new subproblem, and by decreasing the size of my top array, where the top current index now pointing, previously it was pointing to 4 and now it was pointing to 3. In that case where the element does not exist in the bottom array. Okay. Now let's go to this particular case where the element exists in the bottom array. So in that case we have two element of choice. There is an element of choice. So if we try to select that particular element, so now the sub problem will become this only, because 3 is find out at this particular index, which is first index. And now from this sub problem where 0 1 2 3 from the third index, and the bottom index will be pointing to this index which we find out from getIndex -1, so 0. So as you can see here, now if I selected the element, now the sub problem will be of the same arrays but top current index -1, because this will point to this now, and this particular index. I am not sending bottom current index here because bottom current index is pointing to this now, but as we can see, I am sending here index -1, which we find out in the bottom index. So index -1, and here I am doing +1. +1 is for because we are able to create a vertical line, so that's why we added 1. Okay. Now the second element of choice is, if I do not want to select this element, I want to skip this particular element. So in that case my sub problem will be the same, but top current index -1, which is pointing to this 3, and bottom current index. So these are the main 2 points. So where I select, I am sending index -1, but in the other case where I am skipping, I am sending bottom current index, which in this particular example is 2 only. So in case of skip, I will send the same bottom current index, and at the end I am storing in the DP top current index and bottom current index, which is nothing but max of these three's value. Okay, and at the end I am returning this particular DP memoized value. So that's it. That's we have to do is in this particular question. And if you are able to get the intuition after seeing this video, please like this video and subscribe to my channel. Thank you so much.